introduction explain why it is so important to look at the milking machine. For the veterinary students often ask, I'm a veterinary student, why do I need to look at a machine? And hopefully in the course of this presentation, this will become very clear. If we look over the past 20, even 40, 50 years, what has happened, the dairy cow has changed completely. You can see there, first of all, the production level has more than doubled over the years. And they have estimated in the 70s that the production of the peak production, absolutely of the top animals, are now what our average cow is producing. Now, because we've got these animals working at such a capacity, when things go wrong, there is big damage done. And we need to be much more careful in the way we manage them, in the way we look after them, and then obviously also in the way we collect this large amount of milk. If we start looking at the immune system of the animal, because we want to preserve her, we want to look after that she can have a long life, a productive life while she is in the dairy. And to do that, we first look at the natural immune system of the udder, and that is the teat canal. It seems very simple, but it is very, very important in the whole situation, because our other part of the immune system, which is our cellular immunity, the farmers will know it very well by somatic cell count is an indication thereof, is not very effective in the udder, and I'll explain it a little bit later. Even the chemical part of the immune system during lactation is not effective. Or not very effective. So that leaves us with the situation. The best we can do in keeping this animal healthy, the udder healthy, is by preventing the bacteria to actually entering into the udder. Now, in that systematic presentation, if you look at the bottom of the teat, you see that there are the teat opening, which we can look from if we're in the parlor from the outside. And then around that is sphincter muscles that contracts and relax to close that teat canal. And there's a lot of elastic fibers. Now, the problem with that is if they are overstretched, they damage. And the teat canal can no longer close. Now, for the bacteria to enter, what you must realize is the milk is absolutely the best environment for them to grow, the right nutrients, the right temperature. So obviously they're very eager to enter. So if we haven't got that door closed, our new infection rate will sky high. This is a picture where a teat has been cut in two just to show you the teat canal. You can see the length of the teat canal there, and at the inner top of it is a Furstenberg rosette. In there is a lot of white blood cells. It's almost like your tonsils. The last thing trying to get hold of the bacteria, kill them and catch them. And then the other part that is very important about the preventative measurement in the teat canal is the keratin plug. Now, during the dry period, it forms a plug, like you can see in the electron microscope photo. And it's actually like a block sitting there for preventing the bacteria coming in. But the same secretion happens during lactation. It's always secreting keratin. Now, the epithelial cells that lines the teat canal secretes it at a specific rate. And what the keratin does is it is able to, let's say, catch off the bacteria, and it can kill and inactivate of these bacteria. So in between milking, it's hard at work, and when you start milking, the first 2-3 squirts, you remove the top layer of the keratin. And together with that top layer, you also remove then a lot of bacteria that could have entered the teat canal. Now, obviously, once the teat canal is damaged, your keratin secretion is not as effective, or if your machine is, for instance, milking too fast, you strip more of this keratin than normally done. That would lead to immature keratin being on the top layer, and that immature keratin is not as effective in killing the bacteria or catching them, because it's a very delicate balance, the situation here, but very, very effective once it's let to do its work. Now, just a little bit about the second line of defense. So once the bacteria come into the udder, if we look there at the left-hand side, the bacteria comes into the udder. There's a few macrophages in the udder, not a lot of them, because it's not their normal environment, blood is. They identify and try then to phagocytate those pathogens. They send out a messenger, the cytokinins, to ask the white blood cells from the blood to enter, and then they enter and go forth on the process. And depending on how many of these white blood cells, and then also the epithelial and the tissue inside the udder that get damaged, that gets excreted in the milk, and we see it as white blood cells. Now, if we look at the white blood cell, as I said first, it's not the normal environment for the white blood cell in the udder. So when it comes into the udder, there is too little energy, too little oxygen for it to function the same way as in the blood. The pH is different, and the fat cells that's in the blood is seen as a foreign object. So it can phagocytize the fat cell, and then it is not able to phagocytize the bacteria after that. Now you can see, looking at the difference of those two photos, the top one is what it looks like in the blood, and the bottom one you can see much less aggressive once it comes into the udder. The next problem is, now, I don't know who went and estimated this, but they say we've got around about 200 billion white blood cells circulating in our body if we're a healthy adult at any part of the time. And of these, almost all of them are adult cells. Now, it takes about 2 weeks for the white blood cells from a stem cell maturing in the bone marrow to become mature. It lives for 1 to 2 days, some of them a bit longer when it's circulating in the blood. But the moment it comes in the udder, it's got a very short life. And that is part of the problem, that we do not have such a good cellular immunity. Now, the other thing we need to remember is that most of our dairy cows, and for sure the guys on Team R, has got the first 3 months of their lactation, there is oppression because of the negative energy balance on the immune system. So even in that situation, the cow is high at risk. So I hope I've proven my point that it's so important to preserve that teat canal. Now, if you look then at the milking machine, if you look at the top photo, I was told that was the very first milking machine that came into South Africa. You could see it's quite a challenge, I would have imagined. And these days we've got such a sophisticated apparatus. However, we are still at risk when we milk the cow. So what should the ideal machine do? We want fast but effective ways to remove the milk from the cow's udder, but very important, without causing teat damage and udder damage. We do not want to discomfort the cow. In other words, it can be a painful situation if the machine is not set correctly. And then the product at the end, we do not want to lose quality nor quantity by the harvesting process. Now, the things that can cause a rift in the milking machine is basically in 4 different categories, and I'm just quickly going to mention them and explain. The first of all is the way the machine is installed, and it is not always so, and I've seen quite numerous occasions when I come on farms where there might be installation problems. But the height of the milk line is usually the first risk. If we've got a high milk line, it really needs more vacuum, which could be up to 10 kPa more vacuum, to take not only the milk from the cow, but to lift the milk. And we'll see later that by too high vacuum at teat end, that's one of the most dangerous things causing teat canal damage. The second thing that I just want to mention here, if there are maybe farmers listening, we've got quite a few swing over systems, similar like the system on the picture. And in our swing over parlors, the milking line can only be high, above the level of even the head of the cow, because the people has to walk underneath. And due to our large herds, many of our farmers are starting to install the flow meters, which would assist in the automatic takeoffs. The problem with the flow meter sitting so far from the udder in the air, so the milk has to go down with the pipe, up against gravitation before it's measured, gives us a delay reaction time when it should be taken off. And we'll see later, if we take off late, that's a very dangerous situation. Just maybe here, it was a herd I was at, and the wash line and the milk line was connected just with a small little rubber pipe, and they really struggled to get the machine clean. And the main problem here was installation one. All right, the second risk that we sit with is maintenance. And maintenance is a very real problem in the field. Our dairy farmers get the people to come and service the machine, to replace the rubber parts, but the day-to-day and week-to-week maintenance, cleaning of the filters, these things are often lacking on farms. There are so many things to do, and not often this is given a high priority. Now, your pulsators need to remain clean. Here's just a photo that was taken in America, where the pulsators is actually underneath the parlor, kept in a dust-free environment, to show you how important it is. In South Africa, we use filter lines, but a filter can't remain clean if the filter that's supposed to filter the air is not cleaned on a regular basis. So these things are very important to maintain. The next risk is the operation, and that is actually our milkers. Our milkers play such a huge role in the effective milking in the parlor. That is a big challenge, to keep the people up to standard, to keep the people motivated, because this is monotonous work for long hours, and to keep the people to do the right thing is really a challenge. But without them doing their job, for instance, the way they attach, the time they attach, the way they align the cluster piece, how it is detached, our post-milking teat application, the T-dip application, is crucial in the udder health of the animal. Certain things, for instance, here, your cluster is meant to hang on the cow. The whole design is like that, which you can see in the photo on the left-hand side. But I know in our country there are also dairy farmers with, especially with the jerseys, older jerseys, where the udder is low down, where it is lying on the floor. Now, this guy had a good invention, but it didn't seem to solve the problem. But all things like that, because the cluster is not hanging, that it will basically eat deeper into the teat, and the circulation would not be effective. So one of our major problems in the milking process is over-milking. Now, over-milking can happen. That would mean the vacuum is very high while there is very little milk flow at the beginning of the milking, and here the milker plays an enormous role in the stimulation of the lay-down reflex and the timing in which the machine is put on. Overmilking, however, can happen during milking if the settings of the machine are too hard, the milking time is too long, or the vacuum is too long, or even if there is a lot of stress factors in the parlor. Adrenaline is secreted and the lay down reflex is stopped, and then we are overmilking the cow. But most of the time at the end when the takeoff is not correct. So in the first photo, you can see the swelling. It doesn't last long. If the machine comes off, the cluster comes off, you can feel it for a little while. If it was more severe, it is in a ring. And this was a cow that was slaughtered after just 1 minute of overmilking. And that red area is basically veins that burst because of the severe vacuum and in that teat canal. So it is not small changes that can happen. It can be very severe. Yeah, hopefully it's not as bad as this one. The last part of the risk is the settings of the machine. Now, there are ISO standards that gives us indications of how it should work, how fast the pulsations should be, how long we should milk and rest, the work-rest relation. And then the way in which the line is open from the teat, is open, in our B phase is the total milking phase, and how it closes and is then closed again. The D phase we'll talk about a little bit more because it's very, very important in getting the blood, which is so easy to come to the teat, back to the udder. Just a quick example of a pulsograph. If we test the ABCD phases, it should be within the limits, the two sides, because I don't think we've got 0/4 milking machines. Two sides milk when the other two rest, and so we have to compare the two sides that they are exactly synchronized with each other. You can see under C where there's a huge difference. First of all, the C phase is too short, and then they differ from the other side too much, and two of the quarters will be milked out faster than the other two. In this particular farm, there was a problem with adequate vacuum, and you could see the unit closest to the parlor, to the pump, had a higher vacuum than the one far away. The other part of the settings that we can now at last really measure, which we couldn't do in the past, is when the take-off machine should be, or how it should be set. It came a long way from when the first, I think, Waikato was imported from New Zealand. The setting was only at 200 grams a minute. And we quickly realized that this is causing a lot of damage. And we doubled that so that the machine would take off earlier, because our animals has got a high milk production. These days, the new approach overseas, especially in very high producing herds, is to push that up very high. So we sit with a little bit more milk left in the udder, but according to their research, the overall production of the animal is not affected. There are many different settings here, but one setting that I think is very important also is our pre-milking time. That is that the machine won't take off prior to, for a set period right in the beginning, because even if the milk flow is not there, it should stay on to give the cow time to the lay down process to work. In some of those systems, it's very good to have a second milk setting time. In other words, if the machine comes off during milking, or you reattach the machine, that it won't, if there's just little milk, remain for that minute or minute and a half, disregarding the flow, but it will take off after a shorter period of time. Now, the instrument which we can use to monitor is called the Vardia. The Vardia, if you look at those two arrows, we measure the vacuum during milking. At the top, which is the mouthpiece, and there where the red arrow is at the bottom of the liner, and basically depending on the difference in the vacuum between the two, whether there is milk flow, the teat is still filled with milk or not, we can see whether or not the cow is milked out. And if you look at the graph, the blue represents the one measuring the front teeth, the black represents the one measuring the back teeth, and you can see both of them are almost never milked at the same time. So this is an additional thing why we should set our take-off very carefully, that it takes off at least very close to the hindquarters most of the time, which would be the longer one. Now, Mr. Peter Vermaak did his MSc recently, looking just at different settings. Now, it will differ between machine to machine, so please don't adjust your settings. But the machine on this particular farm was set at 500 mils to take off. We changed it over time to get to about 800 mils, which might sound a lot, but what we achieved was the over-milking time was shortened almost by a third. And on top of it, during that over-milking time, the vacuum was much lower, preserving that teat canal much better. The next thing I want to address is something we neglected maybe for many years, is the teat liners. Now, overall, if we look at poor equipment, you can see here from the graph, if you look at new infections, which is the vertical line, and you can see over time the milk flow. If there is machine problems, there is definitely a large increase in the potential of new infections, what we do not want. And to explain it very basically, the main thing is if we get too much swelling, congestion in the teat, we can get hypoxia, there's not sufficient oxygen, and if we look then at the left-hand side, there's insufficient ATP, and then the muscles of the teat canal cannot contract properly, leaving the teat canal open to new infection. If you look around the right-hand side, these can also reduce phagocytosis, so the white blood cells that's in the udder already cannot function properly, and we get a huge new risk of new infection. So what we need to prevent is really that congestion of the teat. We can see high vacuum. You can see again on the vertical line that is your percentage swelling. Horizontal line gives you the time. And the higher the vacuum, we can see it starts off with a lot of swelling. We prefer it not being over 5%, so you can see it can go up to 25%. And it takes quite a long time. 30 minutes, you can see that first one is not even at the level where it should be. So leaving that teat canal open and also then damage the teat canal, tearing that muscle, tearing that elastic tissue. And that becomes a permanent problem. If you look at the teat liner, let's just quickly look at the way it's designed. The top part is called the liner. The bottom part that is underneath the shell is called the short milk tube. And if we look at the liner part, the top is the mouthpiece. We'll talk a bit about it. It goes over the throat and then into the barrel part. So if we want to determine what is the right size for a cow, we would measure the barrel about 75 millimeters below the top of the liner. So once we've got this measurement and we've got a good idea what the teat size is in a particular herd, we choose, so for instance, it would be 25 millimeters average. The animals overall in the herd has got, say, for instance, 25 millimeters bore. We would choose off the liner a bore that would be 1 to 2, like 23 millimeters, so that it can fit very well and snugly to that teat. The reason for that is if we've got two white liners, instead of the teat during milking stretching downwards, it's stretched to the side, And it is very important during the D phase that there is adequate compression to help the blood getting back to the body, which would reduce the congestion. And that is what we really want to achieve. So how do we measure? Yes, no herd has got an average herd size or very close together. There's always variation, but I must say in the animals we've got these days, much less than in the past. So we can have that little instrument measuring it. We put the data into a little program that will, all that round balls is indicating for us the average measurements. So we can see in this particular herds, the level, the length of the teats are very much the same because most of the big round circles are at the same level. However, we can see there's quite a difference in the width of the teats. All we can do, or the best we can do, is take the average, and you can see it is around about 25 millimeters. So in this case, we will select then a 23 millimeter bore liner for this particular herd. The second thing we need to look at the liners is the mouthpiece chamber. That is that top, how deep it is. You get deep ones, you get shallow ones. It is very important to control the vacuum at that place, because if you've got too much vacuum here at the mouthpiece, it will cause a lot of compression into the base of the teat, preventing also proper circulation of the blood. So the shallow ones we normally use for very short teats, as you can see there in the figure. The purple one is virtually, you can't milk the teat. And unfortunately, at the moment, a lot of our high-producing dairy farmers, they are seeing more and more of that very, very short teats. Soon we won't be able to milk them, but even these short teats, the life of that animal is shortened because a lot of edema happens. It can't be compressed and massaged properly. The next thing is the lip on top. If that lip is very hard, it also, you can see they eat into it. It causes much easier the rings, and again, circulation is not good. So we need a nice flexible end to not hurt the teeth. Okay, the next thing is what we call liner compression. There are a few things that we need to take into consideration with the liner compression. The first thing is the teat size. If you've got a very big teat, the liner comes down onto the teat and it must fold round the edge. So there is more compression in the teat, big teats. There's more compression once the teat has been swollen. If you've got very short teats, it's virtually very low compression, so it doesn't help the blood to get out. And our very, very long teats, the liner cannot fold around it, so there's very little compression, a lot of possible damage. The second thing having effect there is the machine settings, obviously our claw vacuum. The higher the vacuum there, the higher compression normally. And then the characteristics of the liner. If you've got high tension on the liner, there's usually high compression. If the liner wall is of a certain thickness, the compression is high, but once it becomes too thick, it can't fold properly and the compression is lower. Now, if we just to illustrate this, we call it overpressure. Now, overpressure happens during the C phase when the liner is folding round the teat. If you look at the graph there at the bottom, you can see the touch point. There is where the rubber touched the teeth. If the compression goes on a little bit longer, we can see it comes to the yellow area where it compresses so much that the milk is stopped flowing. And once we reach that, the fourth area, you can see the green part here is called overcompression or overpressure. Now we do need a bit of overpressure. And if you go to the next slide, I can explain it there. That we need about 8 to 12 kPa of overpressure, because that is massaging the blood to basically go back to the body. If we've got too much, we are going to damage the teat canal, and that is usually a permanent damage. If there is too little, we are going not to help, and the congestion will increase. Very big difference between liner design. Because of the teeth going shorter, they have also designed, if you look at these two graphs, the green graph is a liner that's designed for short teeth. If you look horizontally, you can see there is, but never for teeth shorter than 3 centimeters. It gives much better compression on the shorter teeth because its mouthpiece is smaller. The deeper mouthpiece you can see in the purple one is for the longer teeth. And it makes a huge difference. First of all, the strip yield, so what's left over in the udder, the difference in slipping, whether there is liner slip, and also in milking speed. So the liner plays a much bigger role than we anticipated originally. Other thing about liners is the shape. Most of the liners we use still is the round shape, but we've got quite a few in South Africa, the triangular one. Just the way it closes down, it gives a different compression. I don't want to spend too much time on this. And most of our triangular liners that we've got in the country is vented. In other words, it lets in air at the top into the mouthpiece. This actually helps the airflow and the milk to be subtracted and going into the claw piece, easier to remove it without going into the other sides. What happens during a situation where you've got liner slip. So this is just another graph of the Vadia or the Vadia. If we look at the right-hand side and the top, if you look at the black part, that is the normal pulsation, what you see if you would do a pulsograph, the opening and closing of the liners. The blue at the top is the vacuum that we find then at let's call it the claw or the short milk tube. And then the red one is a non-vented liner. You can see it's a straight vacuum there, whereas the vented liner would be the green one, and you will see movement up and down. And that is during peak milk flow. In other words, from your second minute onwards in most cows. The one at the bottom is then during low flow. It would be when you attach and close to when you are going to take off. And you can see, again, the vented liner follows basically the pulsation of the machine itself, whereas the normal liner is almost a straight line. Now, very, very important not to overuse your liner. This is a question, if you try and save money, it's a question of cutting your nose to spite your face. It is really, once the liner gets old, during the milking performance, we see the milk flow is becoming lower, so you milk for longer time. There is more milk left in the udder afterwards, and there can be, because there is more left, a reduced milk yield. On the udder health point of view, once the liner becomes stretched too much, the massaging action, this overpressure action, becomes much less effective, and we get more swelling on the teat itself. That also affects the natural defense, as I explained earlier, where phagocytosis is not very effective and the teat canal cannot close very properly. And the consequence of that is bacteria entering and our somatics increasing. We also need to remember about the liners. They wear in time, even if they're not used. But UV light, ozone has got an effect on the rubber. Our detergents that we wash them with, especially in places where we've got a lot of hard water and more acid is used to clean the machines. This has got a deteriorating effect. The milk fat is absorbed by the rubbers, and in time they lose their elasticity and they start stretching, as you can see. So it is really not a good time to try and save on that. Now, basically to summarize the effect of congestion, the degree of overmilking will depend on, will basically cause a different level of congestion. So if there's a lot of overmilking for a lot of time, we will see much more congestion. If there are incorrect teat vacuum, too high, or even in some of our machines designs that milks at a very, very low vacuum, that is also not a good thing, because instead of the teat canal being stretched open to the outside, it's inverted to the inside, and it can also cause the muscle and the elastic tissue to actually be torn. The liner fit, as we explained now, plays a big role in preserving the teat's shape while you're milking, and then preventing congestion. And the design, the compression on it, very important also. So if we look from the outside as vet, if you go and inspect the teat or the farmers itself, look very carefully at the color. All of these things is quite severe already when you can see it with the eye. If you overmilked, especially farmers would have noticed your cows that just come into the parlor, very swollen, very edematous just after calving. Sometimes if that machine comes off, the teat is blue, totally epoxic. I showed you previously the photos of the swelling at the teat base when you overmilk. You can sometimes have even swelling at teat end, depending on what the problem is. Openness of the teat opening, if you look at it and it becomes almost like a match that size, just open if it comes off. Very, very difficult to close, and the chances of damage very high. And vascular damage, one can even sometimes, if the machine comes off, see particular hemorrhages, blood spot hemorrhages on the tissue. Longer term, these will lead to the teat canal, the teat end becoming very rough and not able to close, and then there can actually physically be lesions, especially at your teat base if you overmilk. So in that photo, you can see the ring that didn't penetrate properly into the liner, where the ring is, where there is swelling, and if you look closely at the teat opening, you can see the damage already in the teat opening. So we see in the milking becomes less and slower. If we do the pulsographs or the teat in vacuum, we can see the changes here. If you look at the teat itself, we see the congestion, as you see in the photo, and then obviously the changes in somatic cell count and infection of the udder itself. Now, what we must never forget as farmers, and this is for the students very important, what does the farmer want? What does the farmer need? You may or may not know that our dairy herds has grown to very, very large dairy herds. I've had the privilege to be on a few of them just in this last couple of days. But it becomes very important to be able to milk fast. And with that, in the same sentence, I want to say that yes, we must work fast, but we must milk at the optimal level and not maximum level. And optimal will then be determined that we do not damage the udder. So the optimal level that we can milk without damaging the udder. Liner selection, as we said already, is important, but it's usually a compromise. If we've got a liner that milks faster, it will normally milk less complete. If we've got a liner design that won't slip so much, it will be much less comfortable for the cows. So there's always a price to pay. And then what we actually want to have by shorter milking is shorter machine on time. Be careful not to be tempted to set the B phase. That is the time in which the machine is open, longer and longer, or the vacuum higher and higher. because your animals will pay for it, and eventually you too, because their life will be shortened and the life will be, the other health during that would be much less effective. What we actually need from our manufacturers is for each and every liner, we need a map. This is where the liner is tested very well beforehand, and for every particular liner group or batch, there should be this map. Now, how it works, if you look at the the left-hand side, this is, we look at the teat length. You can never get a liner, or at this moment, that will milk without damaging the teeth. And the color index is showing you the more reddish is dangerous, the more green or grayish I see on the one is more the normal, what we do want. So short teeth, we can never milk without damaging them. Our larger teeth, which is the rest of the column to the left-hand side, you can see there we look at the length of the B face, and then we look also at the vacuum level. So for instance, if we look at the grey or the green area, it is to be more careful to milk at vacuum level at the teat, not the system that you see, around about 37 to 39 kPa. And we can see we can achieve 84% of our maximum milk flow. If the B phase is set at 450 milliseconds, and then at the 39. We can also achieve it at 37 with this liner. With 500 B phase, we can achieve 84. So don't be tempted to shift it more and then cause damage to the teats. But this is a great help to set the machine according to the liner. Now, if we look at South Africa, what is happening about udder health here? Are we in a positive, negative situation? Is it becoming better? Is it becoming worse? And in big shame, I must tell you, I'm not sure. We do have, of most of our commercial farmers, their bulk tanks are tested. They've got somatic cell count, they've got plate counts, but unfortunately, this is not done at a central unit. The milk buyers normally does that, and they are not very happy to share the information. So this is not in a national data bank. If you go from place to place, you might get an idea, but overall, we do not know. The second thing that's very sad is that our national milk recording scheme, there is only, and that was in 2021, a bit over 15% of the herds participating. So we get information from there, but obviously it doesn't tell us the whole picture of the country. Now, in the sophisticated milking machine environment, many of these, our Alpros, Alpro, Delpro, or Affimilk, has got this advanced system to help us. And when I looked at figures at the same time, we've got over 650, it looks like, of our commercial dairy farmers of the 1,000 that is using these systems already. So for you as veterinarians, it's very important to start acknowledging this and start being able to use this. Now, to look at the systems, there are many advantages here. It helps you to detect mastitis, more precision milking, so it gives you a good idea what's happening in the machine itself. It's even got a laboratory that can measure butterfat, protein, conductivity, lactose, real time. On the other hand, it's also great help for nutrition, detecting, because of the butterfat protein, detecting ketosis, detecting SARA. It's great now with the new developments. We can also evaluate rumination, cow comfort, how long that animal is lying down. Also gives us an indication when animals' movements are different, whether they're sick. Obviously also when they're on heat, when the calf is due, make it much more precision for us, and also ability to put all that data together to design reports that can help us a lot in proactive management. Again, we want to see before the animal gets sick or when it's at a subclinical level that we can have actions before the animal becomes clinical. Now, just one of these results is the milk irregularity report that we see. You can see the table. So for every milking, at the end of milking, it tells you how many cows has been milked. The multiple attachments is where a unit came off and it had to be reattached. So you can see there we want around about 2%, not more than that. So one evaluate from milking to milking how it happens, whether it is below 2%, and if it increase or the morning or the afternoon or evening milking, if they milk 3 times, are way above the other, one can go and investigate what the reason for that is. Unnecessary attachment, there is where the person think the cow is not milked out, reattach it. As you recall earlier, I said there, if you've got a second minimum setting on your machine, it helps a lot to prevent damage, because if you don't have that and the cow is really a little bit of milk left, you can over milk her for over a minute. Irregular take-offs, it normally happens in the parlor where the milker overrides the system, where the cow is maybe milking for too long, or they are waiting too long and getting eager to carry on. So one can monitor that without being, and then kick-offs is hurting. It is not all that just coughed. High in other groups, there's for certain a reason for it. The other thing that is a very, very handy graph is called the milking curve graph, and it basically shows you the milk flow of the whole herd, or you can get it per group, from the beginning when the cluster piece is coming on till it is coming off. And what is very important here, coming back to the probability of congestion, is that there is a very short period of time that the milk flow will be under 800 milliliters per minute. So if we look at the table, if you're able to see there, one wants really the second last column there, one aims for the percentage of time that it is below to be 10% to 15%. In this particular herd, it's around about 18 to 20. So if we look at the graph, there is a little bit of improvement that we can get at the beginning, but that is not too bad. That would be the stimulation of the animals. But most likely, the take-off time in this particular machine is not set correctly. So we can revisit that and improve this. If stimulation is not good, we can see a bimodal phase. In other words, if we look at the graph, we see a peak, there's milk flow, but that is the milk that was in the teat cistern, the udder cistern. And because there is not a proper lay-down reflex where the muscles contract around the alveoli and press the milk out, it takes a period of time for the milk flow to start again. And this area between the two peaks is then also additional area where the cow is overmilked, which we do not want. What is happening at the moment? If we look at new technology that's being developed, now already the body condition score is being done by the Delpro systems, where it can give the farmer in a much easier manner, less labor-intensive, a body condition score to monitor that. There were studies going on at the university where they tried to look at the claw, where they had actually a transparent surface and they had a camera at the bottom, but yeah, there's quite challenges about that. Lameness scoring, where you observe the movement of the animals, could help also a lot in future. And this was an endeavor we were looking at, that we were actually taking photos of the teat from the bottom to be able to make teat canal scores. And I'm sure in time things like this will become a practical situation. Now, just to round off, your veterinarian, you get the score from the farmer that is telling you it's got really a big problem on the farm, because a cell count of 400,000 from an udder point of view is not sound, but the farmer is also losing a lot of money due to that high cell count in the payment scheme. And he doesn't understand where it comes from. The hygiene looks good, he's confident in his animals. You must come and help. So what do you do when you get to the farm? The first thing to do is and that data is most of the time available, is to establish how many clinical cases there were over the last week, over the last month, that get a trend over a period of time. And our real ideal would be under 1%, but 2% is still acceptable. The bulk cell count, somatic cell count, there you've got the figures. 150 is our ideal we strive for, and a little bit under that. If it goes obviously under over 250, most of the time there's also penalties for the farmer. And then the other information that should be available on the farm is, why do they kill the animals? And you can see how many of them is really due to udder and other problems. The second thing you can look at there, once you've got this information, is if we look at the individual cell count, first of all, of the first lactating animals, we should actually have 90% of them with the cell count below 200,000. So if this is not so, we need to investigate that group. The new infection rate in that herd, and they make often use of somatic cell counts, but your best will be your microbiology, should be under 8%. If that becomes high, the risk, we need to see why there are too many new infections. And then the other thing we need to look at is the existing cases. If the poor rate, our goal is over 40%, this is in lactation. If that is not achieved, why is that? Is it the remedy? Is it a chronic situation? So in the dry period, we also have goals. New infection rate should be low, below 10%. If it's too high, is it the environment? Is it the teat canals of the animals that's problematic? But that should be investigated. If the percentage cure in the dry period, the risk of a dry off should be higher. You can see the best period actually to treat is the dry period. It is something that is very, very important in the whole cycle, the lactation dry period cycle, to get rid of infections that we couldn't get rid of during lactation. But these the figures you can use of. And then at the end of the day, just to give you an indication how the cell count is linked to somatic cell count, in a herd of 400 cows producing quite a high yield, 40 kilograms. In this case, the farmers won't like it. It's a very low milk price of 5 Rand here, but I just fed that into the system, and basically at that somatic cell count, this was, in this case, the somatic cell count that we looked at, the 400,000. The loss per day is 5,500 Rand. Over a month, it's almost 170,000 Rand. And over a year, this loss is over 2 million. So it is really not something to neglect. It will never be zero, but with good management, we can get that down significantly. So just this is one of the ideal cows. This is what one wants. We've got one farmer here, a very good farmer in the Western Cape. For every cow that produces over 1,000 kilograms of milk, he's got a little statue with a number on, and he puts it on a table, and I can tell you there is many, I don't want to lie, but 50, 60, 70 of these statues standing already there. This particular cow remains for me absolutely the ideal, but also a miracle. She is a pasture-based animal. If you look at her there, she is almost 10 years old, and she was in a Till Midlands on the show, the champion there, and she has produced up to that time 100,000 kilograms of milk. So this is the ideal, excuse me, what we strive for. Animal very productive, animal healthy during her life. And yeah, thank you very much. This is maybe the alternative to do with your cluster piece. Thanks very much.
Thank you, Prof. We do have one question in the chat bar. Is there no other milking liners that offer comfort and faster milking as opposed to opting for comfort or milking speed? And also, is there any other companies producing teat liners, as certain mastitis pathogens can inhabit the rubbers in liners? And is there new material that can be used to replace the rubber liners?
I will start with the last part. Yes, there are new material, or there is new material. Silicone liners are on the market. Silicone liners is much less absorbent. They've got a much longer life, around about 15,000 milkings, compared to around about 2.5 of your rubber liners. But unfortunately, there's always a other side. They're more expensive. One of the other problems of there is they can split more easily if an animal can step on them. But we have got systems in the country using them very effectively. And we've got at the moment, for instance, with agalactae, which is a very contagious organism, and I'm sure the silicone liners we are using there, because we can clean them so effectively, is helping a lot in getting rid of that organism and preventing it to be transmitted from the one animal to the other. The first part of the question, I hope I got all of it. There are liners in our country. You do not get one liner that does it all. As I said, it's always a compromise. If the one is kinder to the cow, there's a more probability of liner slip. But basically, it's a situation of where you use a liner, first of all, that fits the teat size of your herd. Second of all is that the settings within that situation is then correct for that liner, as we looked at if we've got that liner graph or the liner table, so that the settings of the bee phase, the vacuum level, are accurate for that liner. And then the management around that whole thing is, first of all, I cannot underestimate to maintain a clean environment, to get your pulsators working effectively, that the one side doesn't work longer than the other side, and your takeoff time is correct. So it's not only the liner, but the combination of the liner, the setting, the operation, the maintenance of your machine. We can have a very effective milking in our country. And I mean, we can see it. That cow, that the photo I've shown you, there are many farms where animals are now being milked for 6-7 lactations, producing while remaining very healthy as well.
How do you deal with a cow with very short teats? No?
You get hold of the genomics, or you get hold of your selection, and you make sure the next generation doesn't do it. But the only way one can really do it. The problem is it's normally your animals, the volume production and the length of your teat is genetically negatively correlated. And that's why we see it in a lot of high-producing cows. And I must tell you, at the moment, I see it both in the Jerseys and the Holsteins, that the teat is becoming less than 3 centimeter. The only way one can deal with it, if you've got a lot in your herd, is by getting they call it the low slip liner, where the mouthpiece is very narrow. In other words, if the teat penetrates into the liner, the rubber parts that would press on the barrel part is very close to the teat then. In the normal mouthpiece, the mouthpiece is much longer. It won't even, the barrel will not even put pressure on the teat itself. So that is a temporary solution. But really the solution at the end of the day, if you see heifers coming in like that, please adapt your genetic selection very, very quickly, because you can have a fantastic animal. If you cannot milk her, that is a problem.
Okay. Yes, we've got another question. You mentioned that it is preferred to increase the cut-off value of clusters to decrease overmilking. How much does this decrease your milk fat?
That's a very good question. They have done quite a few trials overseas now, because there was a lot of work on moving it up to the levels which I showed you there, over even at litre. First of all, they looked at the average production, and what they found is that, as I said, over the whole lactation, there was not a difference. A little bit more milk was left in the udder, 300 ml or so. We preferred 150. That didn't seem to make a difference as far as the udder health, new infections is concerned. And then lately they have looked at the butterfat and really could not find, because it's only 350 and not a lot. If you leave around about a litre left in the cow, that could affect the butterfat, because your butterfat is excreted mainly in your last milk. But if it's set up correctly for your machine, and please don't make adjustments before that has been tested, the butterfat seemed to make, there is no difference. But that is a very, very good question.
Okay, then we have a question from Alex Jenkins. A lot of heat stress abatement can be done by soaking cows in the holding, yet I've heard that this can increase the herd somatic cell count. Could you comment on the sweet spot between somatics control and heat abatement during our hot summer periods?
Yeah, that is not a very easy answer. There's been lately quite a lot of work done where they looked, one of our veterinarians also did a on that, looking at heat stress and somatic cell count. The main issue here, the reason for heat stress, or the reason is the stress, any stress on the animal will increase the somatic cell count, irrespective of whether there are bacteria in or not. Now, with the when we move the animals around, try to cool them down, the major situation is there that we try and keep the environment in which she is going to lie down still sound. In other words, to keep it dry, to keep it as much as possible, and to lower her temperature. But I cannot really give you the answer here. It's a toggle up, and like you say, that's the sweet spot that we need to look for between how much movement, how much cooling down in comparison with before we start stressing the animal further by the movement than by the heat stress.
Okay, we always talk about high somatic cell count, but how low is too low?
There's a little bit more about somatic cell count than just the numbers. We start getting careful once we go under 90,000, 80,000 bulk cell count. But besides that, because we need a little bit of cells there at the teat end, and maybe I can explain you, when we do research, we sometimes do strange things. We did a research project many, many years ago where we actually put a little piece of plastic, which we eroded chemically or mechanically through the teat canal to bob up and down there in the teat cistern and the udder cistern. The whole idea about that was we wanted white blood cells to be there at the place if the bacteria enter, that they can deal with them immediately to prevent them from multiplying. It worked very well for about 2 months. It was only the cell count in the very first milk that was increased. The new infection rate was down because we could manage the bacteria coming in much better. But after about 2 months' time, milkstone settled on this device and it was back to normal. Now, the whole situation with the somatic cells is they're not just the amount, but how fast they can get to the place. And this would be, if you record right in the beginning, we were talking about the negative energy balance that actually suppress the immune system. And one of the ways it would do it is that the reaction time, if cells are needed in the udder, they become much slower. Also, this happens in a chronic infection. If the body continuously say to the udder, I need more cells, I need more cells, they get depleted. They can't be matured fast enough. And we get also immature cells circulating, which is much less effective. Now, I know I gave you probably more mouthful that you wanted, but I would say not below 90,000 bulk cell. And in this situation, the immune system of the cow must be intact, that she's got adult white blood cells circulating with a fast reaction time to be able to cope with the problem.
Thank you, Prof. What is your opinion on genomic selection against the immune system, the somatic cell count of the udder? And is there any new scientific method of measuring immunological cell reaction time?
I think genomics can really make a big difference if used correctly. We get now the opportunity in a very young animal to start selecting. We know how much it costs to actually bring up an animal, get her into lactation. So if we can already select against immunity, and that has been proven to be effective, together with obviously good management, the other health part of it. It is just, I had a conversation with a farmer yesterday that is concentrating only on the production side. So when you are using genomics, it's very important to use a balance in what you're going to select for. So yes, it's got a great possibility, but we need to learn to use it very effectively to have a balance in our selection. If not balanced, we can very fast move into one direction. And I believe nature is like a pendulum. If you push it too hard to the one side, it will push back. So in short, I really think it's a good opportunity. We just need to be very careful how we use it.